we are going to be all super excited right now. So you ready? So class.
Yeah.
Okay, wow, that didn't sound exciting. All right, so for those people that are not super geniuses and have not already done all this, and you know, for fun, we're going to go over. So what this is actually the fundamental theory of calculus part 2. So what we're doing is actually going to be the upper bound and subtracting the lower bound when I find the integration of f. And so in my notation of this, it goes into a capital F. The capital F says that was the integration of f, where when I took a derivative of f, I put the tick mark for f prime. So it's the integration of b minus a. So parentheses are always good on this one right here because that's where a lot of people are going to screw up. Yes? Are we okay there? Okay, good. All right, right here. Integration of x squared is going to give me x to the...
I didn't do the first part of these notes, I'm just guessing.
No, it's all integration. It's all integration. It's the same rules that we've been doing. So if it's the opposite derivative, now think about this. If it's the opposite of derivative, I would take the exponent and put it where? Out front, right? And then I'd do what to my exponent?
Oh, it's this. So it's x cubed.
X cubed. And instead of actually, so what would I do with that number? Remember, derivative, I take my exponent and put it out front, right?
Yeah, so would it be divided?
Very good, that's what we do. So this is going to turn into x cubed over 3 from -2 to 1. So there's my bounds. Yeah.
Is there no plus c?
No, because if I have this right here is going to be f of b plus c minus f of a plus c. Yeah, it's going to cancel out because right here, when I subtract the f of a, this gets over to here to be a negative c, where this right here is a positive c, and so therefore the c goes away. So we're actually talking about with bounds, this one is going to be no c on this.
Okay.
All right, so right here, this is going to turn into, I plug in the front, which is going to be 1 to the third over 3 minus my lower bound, which is going to be -2 to the third over 3. So that's going to give me 1/3 minus -8/3, which is going to turn into a plus, which is 9/3, which comes out to just be a positive 3.
Is on the bottom row that next to that 1/3 plus sign? What is?
Yeah, they turn it plus side. My penmanship is horrible right now. Smartboard will slowly start getting a little bit better, like less choppy. But yeah, that's a plus sign because the two negatives made it to a plus.
And then that's an 8.
Yeah, that's an 8.
Oh,
Because yeah.
and that's a 3.
Yeah, it's better than actually how I used to do my 8s. That right there turned into a lot of people thinking it was 5s. Or, even better, that's my F. That's my F right there. So, when I started teaching calculus, I had to change the way I wrote numbers. So,
Do you do like the dash in the 7s?
yes.
7s, my 4s, and my 9s all look like the same.
Yeah, so my 7s have have it, and then my z's, I always have to cross my z.
And I cross the Z's and zeros inside.
So, yeah, it's one of those things. Alright, so I'm gonna new page, cosine from 0 to pi over 6. Yeah, it's x. Okay. Alright, so remember, the derivative, okay, remember, derivative had a circle for sine and cosine, so antiderivative is the same circle, it just goes backwards. So what is the integration of cosine? Positive sine, right? Okay, so I have positive sine of x from 0 to pi over 6. So upper bound, what is sine at pi over 6? Think of a unit circle, pi over 6 is gonna be the smallest one, right? So, yeah. So I think about it, so if you think about it in your mind, it's a smaller value, so that means that it doesn't go up very much, so that means that the x value is bigger. Rad 3 over 2 is bigger than 1/2. That's the way I always memorize it. Wherever that I know the location is, the x and y, it's either rad 3 over 2 or 1/2. So whichever's bigger. So this one's sine is going to be smaller, so this is a positive 1/2 minus, what is sine at 0? Sine at 0 is 0. There we go. So my answer is 1/2. It's not so bad, right? I know it looks crazy at first, but then you're like, oh, hey, it goes by the same rules that we've been doing. Next one is 1 over square root of 1 minus x squared. And that was to what? Rad 3 over 2. Okay, this one right here, I don't expect you guys to have it all memorized right now, but does this look familiar? When we did derivatives, I remember something like that. That had something to do with an arc, didn't it? That arc what?
Arc sine?
Yes, it is. It is arc sine. So that right there, arc sine would give me this in my derivative. So therefore I could work backwards and say this integration would be arc sine. Arc sine of x from 0 rad 3 over 2.
Mr. Pasha,
Yeah.
what's the real world application of arc sine?
That's using the angle instead of actually having the value. So when we actually do these things, and if I say, oh, what's the sine of 45 degrees? Okay, that's really not in an application of what we're doing. So we're normally going to have a value instead. So I'm going to use this geometry because I am making something. So this is, I'm building something. Okay, and now from here, I need to actually break it up into parts, and then I know certain values. I don't know what the angle is, so, but I know this is 4, and I know this one is 11. But I need to try and figure out what that is, and so from here, this theta, instead of saying sine theta is equal to 4 over 11, I would change it to arc sine of 4 over 11 is equal to whatever that is. So in in actuality, you could do all this to actually help you with this area to figure out what you're going to do there. Because otherwise you would have to go through and find this one also, and you know, that being a right angle, yes, you could do all that. but then you would have to actually do this one first, and then do the area of a triangle, which is 1/2 base times height. But this is less work to actually just go straight to here, because we could do area of a triangle using AC, yeah, AC sine A, sine C, one of those. So yeah, using the law of sine, you could actually find the area. Anyway, alright, but yeah, that's a real world application. Instead of actually doing all that other stuff. So it's funny, since I now teach engineering, I actually use that more. So in my 20 years of teaching, 20 plus years of teaching, never really actually had a reason to use it until now. So anyway, so arc sine of this is this, so now let's take a look. This has a domain restriction, and my domain restriction is going to be from, let's see, it's going to be negative pi over 2 to positive pi over 2. Where on my unit circle in quadrant 4 and quadrant 1, where on is there is the sine value rad 3 over 2? Pi over,
Or no, 3.
pi over 3. That's going to be pi over 3. That's what I'm doing. So right here I have a value. I want to know where this one works at. So this is asking, where is sine this? It's pi over 3. So pi over 3, so sine of pi over 3 is rad 3 over 2. Where is sine equal to 0 within that window? It's at 0. So that would be 0. Christian looking at me kind of crazy. You good? Okay. Still just pondering? You have a question? Okay. Alright, let's get this next problem. Next one is right here from 1 to 2, 1 over x dx. Alright, when we went back, think back of our derivatives. What gave me a derivative of 1 over x? ln, very good. That's ln. And I'll show you why this doesn't work. Okay, I would rewrite this, so this is wrong. For those people watching, this is wrong, okay? So I'd rewrite it x to -1, right? And then it would be to take the integration of this, you would think it would go add 1 and then divide by that number, right? So that would be x to the 0 divided by 0. So my integration does not work here, because the steps I have been doing every single time does not work here. That's the reason why that when we had 1 over x, because everything in math, every opposite has a, or everything in math, everything that we do has a opposite that has to undo it. And because this did not undo my 1 over x, that's part of why we have the ln. But, there's also a lot of real stuff to go along with it, besides just that failing. But just to show you, if you ever tried doing that, you'd be like, oh, 0, okay, so there's something else. So it's ln x ln of absolute value x, and that's from 1 to 2. Now, there's a reason why it has to be absolute value. Can I have negatives inside there? Do you remember what the graph of ln is? Bless you, Christian.
Thank you.
Isn't it all positive? The graph of ln is all positive. There's nothing in the negatives. So I cannot do a negative in there. So ln2 minus ln of 1. And this is something that it's gonna behoove you to try to memorize. What is ln of 1? 0. That's where it crosses the x-axis. So it's gonna be 0. So this is going to save you a whole lot of time, effort, and brain aneurysms, is just knowing that ln of 1 is going to give me 0. So my answer here is just going to be ln of 2. So, is that good? You feel good about that one, Christian?
Yeah.
Okay, so right here. Okay, how many more do we have? We have this one, and we have a couple more. So I'm just gonna do this one here, and then we'll help you with homework if needed. Alright, so right here, it says find the area under the graph of f of x equals e to the x from -1 to 1. I wanna rewrite this first. I would rewrite this as, anyone? E to the x. Am I forgetting anything? So the integration from -1 to 1. Anything else? Dx. This is important. If you don't remember the dx, it's going to mess you up. And once we get to the AP calculus, more like how to write your answers in this sense. If there was like a 2x squared plus 5x plus 3, and then you just put the dx right there, this would be incorrect. So it was kind of weird. They made a big deal about it for a bunch of years because they would only imply that this goes with that dx. It's stupid. Yeah, that was stupid. I don't know if they're still doing it, but that's one thing I'm just encouraging everyone to do anyway. Just parentheses. Alright, so what is the derivative of e to the x? E to the x. What's the antiderivative of e to the x? E to the x. So I'm going to have e to the x from -1 to 1. So that's going to give me e to the first minus 1 over e to the first. Yeah, I'm just going to leave it. That's it. You can get approximation off of that, but, don't really care that much. Make sense? Yeah? Okay. Alright, I'm going to leave you off, and any questions on the homework, I will come around and help. Make sure you like, share, and subscribe.